You are listening to The Vocal Technologist. Spoken tech for your ears.
Imagine an attacker breaching your network. Like, how long do you think your IT team has to stop them before your data is just gone?
Right, you'd think maybe a day, or at least a few hours.
Yeah, exactly. But, well, if you look at this dense stack of information security bulletins we have from late May 2026, the answer is exactly 22 seconds.
Which is just a profound paradigm shift. I mean, for decades, the friction of a cyber attack, the time it took a human to, map a network, find a vulnerability, write an exploit that was the defender's greatest advantage.
And now that friction is just gone, completely evaporated.
Exactly.
So for you, the learner tuning in today, our mission for this deep dive is to cut through the noise of all these recent reports. We want to extract the really critical insights you need to understand this new reality.
Because the old cybersecurity playbook is officially dead.
Right. The one where you just watch firewall logs and, hope nobody guesses your password over a long holiday weekend. That era is over.
Yeah, we are no longer defending against human keystrokes. We're defending against autonomous agents operating at machine speed.
Okay, let's unpack this. Because this 22-second number, it just sounds unbelievable. I saw this in the report from Google Cloud's COO, Francis D'Souza, right?
Yeah, that's the one.
So what exactly is happening in 22 seconds?
So that is the attack chain. It's the time from the very initial breach of a system to the attacker successfully handing off that access or, executing their primary objective.
Just 22 seconds from breach to handoff.
Right. Think about the compression of time there. Historically, human defenders had a window of maybe like 8 hours to detect anomalous behavior in an isolated machine.
Which already felt fast for an IT team.
Oh, absolutely. Yeah. But a 22-second window means human response is mathematically irrelevant.
Wow.
If you're relying on a human analyst to get a Slack alert, look at a dashboard, and click a button to block an IP address, the attacker has already packed up and left with your data.
That brings up something I saw from India's CERT-in. They just published this radical new guidance responding to these speeds.
The 12-hour patch window, right?
Yes. They're mandating a 12-hour patch window for known exploited bugs on internet-facing systems. And they explicitly point the finger at agentic AI, specifically frontier models like GPT 5.5 and Mythos as the accelerant here.
It's a drastic move.
But I have to push back here. A 12-hour patch window. That's like being told you have to completely rebuild your car's engine while driving 80 miles an hour on the highway.
That is a very apt analogy. It sounds like an operational nightmare.
Right. I mean, how can any IT team realistically test and deploy a patch that fast? Think about a hospital blindly deploying an update in 12 hours. They could break their entire patient portal.
I completely understand the skepticism. And, if you view it through the traditional lens of patching, it is literally impossible.
So what are governments genuinely expecting them to do?
Well, what we're really talking about here is containment strategies. The mandate isn't a literal patch completion clock where the vendor's software fix has to be perfectly deployed.
Oh, okay.
It's about isolation, access restriction, or disablement.
So turning an impossible deadline into a feasible mitigation response, like stop the bleeding first.
Exactly. If a severe vulnerability drops, you geo-block the traffic or you literally pull the system offline. You apply a tourniquet because AI speed attacks are not going to politely wait for you to test your patches.
That makes a lot more sense. And looking at these reports, we're seeing exactly how these AI models are being weaponized. Trend AI Research detailed this solo Russian-speaking hacker they track as Bandcampro.
Yes, the Gemini jailbreak incident.
Ah, right. Now, a quick but crucial note for you listening. The source material details that this hacker was running a, quote, MAGA-themed influence operation and generating QAnon posts.
Which is a very charged context.
Very. So we need to be crystal clear. We are impartially reporting the facts exactly as they appear in the source material. We are absolutely not taking any political sides or endorsing any viewpoints here.
Right. We are solely looking at the technical mechanics of the breach.
Exactly. So mechanically, what did Bandcampro actually do? Because they managed to permanently jailbreak the Google Gemini command line interface.
Yeah, it's a masterclass in subverting these new tools. They targeted a specific memory file called gemini.md.
And what does that file do?
The command line interface reloads this file every single time it starts a new session to remember user preferences. So the attacker planted safety disabling instructions inside that file using Russian language prompts.
Wait, why Russian? Why not just tell it in English to turn off safety?
Because the safety guardrails for most of these major AI models are heavily trained and optimized in English. By navigating the system in a different language, they bypass the AI safety controls entirely.
Wow. Okay, so the safety is off. What did the AI actually do once it was unleashed like that?
It basically became an automated cracking machine. The AI generated up to 20 password mutations per target, specifically tailored to crack WordPress admin accounts.
20 mutations, like per second.
Yes, it analyzed stolen data logs, understood the victim's patterns, and just instantly mutated the passwords until it cracked them.
And this brings us right back to that 22-second window. The AI is doing all the tedious manual credential stuffing in the blink of an eye.
Precisely. But, if we connect this to the bigger picture, this AI speed is forcing a massive shift in how attackers view identity as a whole.
How so?
Well, if attackers are moving at AI speeds, they aren't wasting time trying to break down the front door. They're simply stealing the keys.
Oh, right. We always hear identity is the new perimeter, but the data from CrowdStrike, the FBI, and Verizon in the stack is pretty wild.
Yeah, the numbers don't lie.
Like in the financial sector especially, attacks are bypassing password theft entirely.
Passwords are old news now. What they really want is the token.
Okay, for the learner tuning in who might just use Face ID and move on with their day, let's clarify that. If a password is your concert ticket, a token is the wristband they give you after they check your ticket and your ID at the door.
That's a perfect way to think about it. The token is issued after you've proven who you are with your password and your multi-factor authentication, your MFA.
Right. And once you have that wristband on, the security guards inside the venue stop asking to see your ticket.
Exactly. And these modern attackers are going straight for the wristbands. Take the mutant spider group, for example.
Oh, yeah, I read about them. They use Microsoft Teams to run phishing attacks, right? Like voice phishing.
Yep. They don't guess passwords. They literally call up a company's IT help desk, talk their way into getting the victim's MFA reset, and then register their own device.
It's just simple social engineering. But it gets even more automated, doesn't it? I saw something about a platform called Kali 365.
Yeah, Kali 365 is terrifying. It's a phishing as a service platform that costs just $250 a month.
Only $250.
Right. And it captures Microsoft 365 OAuth tokens using legitimate device code flows.
Wait, legitimate device code flows? How does an attacker abuse something legitimate like that?
Well, a device code flow is meant for devices without a web browser, like a smart TV. The TV gives you a code, you log in on your phone, enter the code, and the TV gets a token.
Okay, makes sense.
But attackers just trick victims into entering these codes on fake login pages. The victim's legitimate login generates a real token, but the token is sent directly to the attacker.
That's insidious. And the reports also highlighted a tool called road tools being used by nation-state actors like APT29 for intra-ID enumeration.
Yes, Road Tools is an open-source Python framework. It was originally a red team utility built by security pros to test their own systems.
But wait, if tools like road tools operate entirely through legitimate Microsoft APIs, aren't our traditional security alarms completely useless? I mean, how do you catch a thief who looks exactly like the homeowner?
If we connect this to the bigger picture, that is the defining challenge of cloud security today. Captured tokens become credential equivalent bearer artifacts.
Meaning the system trusts them implicitly.
Exactly. Because the MFA fired successfully on the victim's legitimate device during that initial trick, traditional credential theft monitoring never flags it.
Wow. And it's not just enterprise systems. This token and identity crisis is hitting consumers too, like that bizarre Google Family Link exploit.
Oh, that one is terrifying.
Yeah. Attackers get a hold of a victim's session cookies, go into their account, and change the victim's birth date to make them under 13.
Right, which automatically triggers Google's child protection features.
Exactly. Then the attacker links the victim's account to an attacker-controlled parent account. And because the system thinks the victim is a child, it overrides all their 2FA and permanently locks them out of their own digital life.
It's a devastating weaponization of protective logic. But, it gets worse.
Worse than permanently losing your Google account.
Well, we've talked about how they steal identities to access finished systems. But what happens when the very code environments developers use to build these systems are already poisoned?
Ah, the software supply chain. Right. If you're a developer listening to this, you really need to hear this part. I was looking at this malware campaign called Trapdoor.
Spanning NPM, PyPI, and crates.io, right?
Yes. And it specifically targets and tampers with AI coding assistant files on a developer's machine files like .cursor rules and keylawue.md.
For those unfamiliar, Those files are essentially instruction manuals that tell a developer's local AI assistant how to behave and what rules to follow.
So what does Trapdoor do to those instruction manuals?
It injects hidden Unicode instructions into them.
Right.
These are specific text characters that are completely invisible to the human eye in a text editor.
But the AI still reads them.
Oh, exactly. By slipping these invisible instructions in, the attacker silently tricks the AI into suggesting vulnerable code or tells it to ignore major security flaws during automated code reviews.
That is deeply unsettling. You're hacking the architect's blueprints before the building is even built.
We are moving from opportunistic package abuse to workflow-level compromise. A single developer workstation is now high-value, production-adjacent infrastructure.
And the attackers are getting so creative with delivery. Look at the Laravel-Lang supply chain attack. They bypassed the official repositories entirely.
Yeah, they abused GitHub's version tagging system.
Right. They made a malicious fork of the official code.
Yeah.
And then somehow pointed the official version tags on GitHub to their malicious copy.
So anyone running an automated update downloaded the bad code, and the attackers never even hacked the official repo.
It's crazy. And then there was that Perk Brioche 4 campaign. They inserted malicious post-install hooks into package.json files.
Right, mimicking an SSH daemon.
Yeah, it saved a payload to /tytemp/.tyshes on Linux machines, hiding right in plain sight. At least GitHub is adding staged publishing to NPM now, requiring 2FA for maintainers to approve pre-built tarballs.
Which is a good step. But it feels like we're constantly playing catch-up. Because even if you secure the developer workstations, what about the foundational hardware we trust implicitly?
Oh man, the Apple M5 chip vulnerability, this blew my mind.
The memory integrity enforcement bypass, yeah.
Apple introduces this state-of-the-art MIE physical hardware memory tagging on the M5 silicon, and a 3-person team at Caliph defeated it in just 5 days.
And they used Anthropic's restricted Mythos preview AI model to help them do it.
But how do you break physical hardware logic in 5 days?
They found an integer overflow in a specific bounds check, the Zialic Ramut check.
Okay, an integer overflow is that, like, when a car's odometer maxes out at 999,999 and just rolls back over to 0. That is a perfect analogy. The system tries to store a number too large for the memory space, and it wraps around. The researchers used the AI to hunt down this obscure math flaw to flip a victim process's ID directly to 0.
Which is root access, right?
Yes, without ever actually touching the hardware memory tags.
It's wild that AI broke hardware logic that fast. But here's where it gets really interesting. Because sometimes attackers don't even need complex AI exploits.
Like the Lightspeed cPanel 0-day, CVE 2026-481722. Exactly. It's a CVSS 10.0 maximum severity. It allows any authenticated user to escalate to root access with a single, malformed API call to something called lsws.readdisable.
It's a catastrophic logic flaw. No complex exploit chains, just one bad API call.
Speaking of bad logic, we have to talk about the Google API key deletion delay.
Ah, the Aikido research.
Yeah. They found that deleted Google API keys remain usable for up to 23 minutes. I mean, think about that. It's like calling your bank to cancel a stolen credit card, but the bank tells the thief, hey, you've got a solid 23 minutes to go wild at the mall.
And at AI speeds, 23 minutes is an eternity. Attackers use this window to rack up over $10,000 in Gemini compute bills.
$10,138 to be exact, on a supposedly deleted key.
It's at architectural latency. It's a critical vulnerability now.
So when all these defenses fail, the tokens, the code, the chips, the APIs, what happens to everyday people?
The real-world data fallout is just catastrophic.
Yeah, it really is. Just rapid firing through the late May leaks. 600,000 Lithuanian records stolen by a foreign entity exposing military personnel.
Then there's the UK visa portal, leaving 100,000 passports on an unpassworded cloud repo with a predictable URL.
Paytel exposed 300,000 prison callers' IDs. And Gitea left 30,000 deployments private container images readable for 4 straight years.
4 years. But what's fascinating here is that attackers don't always need new 0 days to cause this damage. They rely on massive networks of zombie infrastructure.
Zombie infrastructure, like the Rondodox botnet.
Precisely. Rondodox is currently hijacking over 1 million exposed ASUS routers, and they're doing it by exploiting CVE 2018-5999.
Wait, 2018?
It's a critical vulnerability from 2018.
Yeah.
I'm going to pose this directly to you listening. What stands out to you when you hear about an 8-year-old router bug still being exploited at this scale in 2026?
It's shocking. These are forgotten devices sitting in people's living rooms, just fueling global cybercrime.
But authorities are fighting back. Look at the global takedowns in this stack of reports. First VPN was completely dismantled.
Right, that service was harboring 25 different ransomware groups.
And there's the Glassworm botnet disruption.
Mm-hmm.
Defenders severed 4 deliberately resilient command and control channels simultaneously.
Glassworm was the one using Solana blockchain memo fields and the BitTorrent distributed hash table, right?
Yeah, and even Google Calendar event titles. But the takedowns of First VPN and Glassworm prove something crucial.
What's that?
Defenders have to target the underlying financial and indirection layers of the infrastructure. You can't just play whack-a-mole with individual malware files anymore.
Wow. Okay, let's take a breath and recap this journey for everyone. We started with 22-second AI attack chains. We moved through stolen MFA tokens and poisoned developer environments.
Right?
We saw fragile Apple M5 chips defeated in days, culminating in these massive real-world data leaks fueled by zombie routers. It's a lot to take in.
It is. And it leaves us with a really provocative final thought to mull over, based on this overarching theme. It's the dual-use dilemma of identity and AI tooling. Think about it. The exact same administrative tools like road tools and AI systems designed to secure our infrastructure are being natively weaponized by nation-states and botnets to dismantle it.
Using our own tools against us.
Exactly. So will the future of cybersecurity require organizations to actively hobble and restrict their own administrative capabilities? Will we have to intentionally limit our own IT teams just to reduce the attack surface?
Man, breaking our own tools just to stay safe. That is a wild thought to leave off on. Well, thank you for joining us on this deep dive into the source material.
Nothing great.
Keep questioning the systems you trust, and we'll see you next time.
Spoken Tech for your ears.